So we're going to start. And once again, I will introduce myself. My name is Olena Borzenko. I'm a senior software engineer, senior backend engineer, depends on the company and product actually, but currently I live in Germany, in Berlin. And I'm originally from Ukraine, and I think that I live in Berlin for already like 2 years. Currently, I'm working in a company called the Adecco Group. It's HR global solution. And today's session, going real time using Azure CosmosDB and React, I want to present based on a small demo, basically prototype of the warehouse system, which I had an opportunity to build or actually start building with my previous company. So warehouse system, the idea was for us to be able to track the movements which are happening in the warehouse, how the product are getting transferred from one place to another. And for us was very important to, based on this information, be able to calculate stock information and warehouse state. Of course, this information we want to have in real time. Once something was moved, we want to immediately display all the changes. And we came up basically with an idea structure, like how to handle it on Azure, how to basically take all the bricks which Azure offers us and build a simple dashboard with a persistent data store with real-time functionality and minimum code, because we decided to use Function App in Azure Functions. So in our case, when we were receiving movement event, we were writing this data to Cosmos DB. And Azure CosmosDB has a great feature, which is called change feed processor, Azure Cosmos change feed, sorry. And every time when there is a data getting updated or created, change feed saving the document on every update, on every change in the database. And this is persistent event store. So CosmosDB has our data, and change feed has a history of everything what happened in our database. And we decided that we will react on changes in our CosmosDB, and we will have two other Azure functions. Whenever movement is happened, we will update state of our warehouse, and we will calculate stock information. So we will create materialized views, and we will have pre-calculated queries. Anytime we need it, we can just fetch data and show it on a monitoring dashboard. And of course, it was saved in Cosmos DB. So this gave us a lot of flexibility. We had small blocks, we had our data store, and we could, anytime when we need new functionality, just add more and more Azure functions. We can scale it. It's independent like blocks of logic, of system. And it was super easy to handle for us. Like everyone in the team was working independently. And when the question came how we can actually grow it, like what next we can do. So now we can write data, now we can calculate some materialized views. Now after this, we decided that we want to show this information. So create a dashboard, monitoring systems, maybe put some displays in the warehouses so employee can actually see some numbers. And from the previous picture where we had Azure function to calculate our stock, when we were writing it back to CosmosDB, we were doing exactly the same thing with just change feed. We were reacting on those changes, and again, we're using Azure function to get with HTTP trigger. And Azure function was connected to Signal R and was notifying Signal R that there is some changes happened. And of course, after this, our data was populated and pushed to our clients. So this gave us, basically introduced us simplicity. We built the first part of the system from bricks and like blocks, like Lego pieces. And when we wanted to extend it, when we wanted to add more functionality, we were basically using the same bricks, Azure functions, a change feed, and it was easy. Everyone was already familiar with what is happening, how it works, and it was very easy to extend our system. And so function app itself, it's basically, it allows us to concentrate only on business logic, because it's removes from us a headache from like how to host it, how to maintain it, scale it. Azure makes everything for us. Well, basically that's why we pay for it. And in our case, we decided that we will use different HTTP triggers and CosmosDB triggers and different bindings, CosmosDB binding and Signaler binding. And this gave us, as I already mentioned, less code. So using those bindings and triggers, especially bindings, for me it was like magic. I just specified that I want to connect to a database and to a specific container. And every time when my function was executed, the data was automatically pulled in a function, and I had no need to create some servers, some like repository layers, absolutely. And let's do a demo. I want to show actually how simple the implementation itself looks. I have my project where I have 5 Azure functions, only 3 of them actually like business related, no, 4 of them business logic related, and 1 Azure function will have a negotiating point to allow our clients to retrieve information about Signaler service. So first function to create movements basically has a HTTP trigger and CosmosDB binding. So we can call it as just an API endpoint, and we can say that in our warehouse database, in movement container, when we will receive some data, we just want to save it back. And the logic is very simple. We just create like one movement, and we add it to a collection of documents, and that's all. When the Azure function will finish execution, this will be automatically saved to our database. After this, to be able to retrieve our data, we basically created similar Azure function with HTTP trigger, but in this case, we used CosmosDB input binding. So whenever we called Azure function, automatically this data from stock per location container was pulled. And as we see here, I'm not doing any calls, nothing is happening. I'm just returning all the data I just received here. And the amount of code, I mean, for me, it looks quite like a bit of magic, but it simplifies a lot. And next function, basically an actual business logic, how we can calculate our stock information, warehouse information. And here we are using CosmosDB Trigger. This is exactly the trigger which will react on changes in CosmosDB. We are listening to movements container, and here we are just deserializing our data, handle some changes, making some operations, and saving back our data to CosmosDB, but already like pre-aggregated, pre-calculated queries, so we will have much less views. And negotiating point, as I already said, it's just trigger and to receive Signaler connection information for our client. And yeah, and this Azure function will react on CosmosDB changes on change feed, and using Signaler binding will send and will push notification to a Signaler service and say, hey, I have some data, it changed, there's your target, notify our clients. And that's basically all implementation. So I have like 5 small pieces, small functions. I deployed them, I hosted them already, published them already on Azure. And yeah, there is my function up. And there's my functions which are already published. It's super easy to publish on Azure. We just need to connect to basically our Azure account and right-click on a project, publish, to select our function app, and we are good to go. So we have our functions, we have our business logic, and we have also a UI client, which is written on React. So what is exactly React client? How does it work? How does it connect to our Azure functions? As already, I'm sorry, wrong slide. Okay, so happening. That's our UI application, and once we are starting our application, we are calling negotiate endpoint our Azure function, and we don't know. We have no idea what is our signal, our service. We know that we just want to receive configurations, and once we have this configuration, we can establish connection with an actual signal or service through WebSocket. And once there is some updates, or maybe our data changed, whatever happened, Signal binding will push this data, and Signal service will send data to our client. On the client side, it looks in a way that we have Hub Connection Builder. So we basically using, of course, I'm using Signal package. I don't want to implement all the functionality on my own. I'm using Hub Connection Builder. I'm providing which exactly URL to which Azure function I want to connect. Where is my negotiate endpoint? And I'm starting the connection. There is not much of a logic. It's very simple. It's very easy to connect when there is a package already implemented. So that's how we can receive some Signal messages. We using the connection which we already started before. We providing the event name we are listening to, and that's basically all. When Signal service will push some data, we will receive it here, and we can do our logic, process our data. And let's go back to our presentation, to our application. And I want to show how it actually now works in a actual published functions and our UI application. I don't have any data yet in CosmosDB. Here is my containers. They already created here, but data is empty. And stock per location, it's also empty. I just want to trigger creation of a few movements to show basically how does it look like, the movement itself, and how the stock per location is created. And I hope that demo will work. Yes. So here's our document, and basically nothing special. As I said, we just handled how our product was moved from one side, from one shelf to another, or from one location to another. We have our article name and whatever other information we need. And it's simple documents, they were auto-generated. And in the same time, our Azure function for calculating stock information was already up and running. And once my movements were written in a database, stock information was already as well generated and calculated and saved in CosmosDB. As we can see here, we have a location ID, location information basically, and we have some checkpoint information. So which article was here and which quantity is of this article. Here's some more articles. Yeah, so that's basically how what is called materialized views. I didn't create, I don't have any endpoints to specifically insert this data in my database. I'm just reacting on changes which happened on the triggers. So I have one source of truth, I have my movements containers, and there is the same data will be used by all Azure functions. So it means that my data will be always consistent, and whatever I need to add more clients, more functionality, I can just connect Azure function, create new Azure function, new logic, and pull the data from change feed, from movements container, and generate materialized views for a new client with the all data which already exists in database, which is really a great feature of change feed. It's not only saving the history and all the data which came in CosmosDB, but also allows us differently pull this data as in a way which is best for our use case. And we will talk, my session basically called real-time applications. So I just showed how the Azure function was triggered itself, how the creation of movement was happening, and how the calculation of stock working. But now, if I want to see my data basically in real time, I just will trigger interval, will just randomly start calling Azure functions with like a couple of seconds difference. And as we see, the Azure functions was triggered to create movements, and all the other functions, they are also working automatically on triggers, and signal are pushing changes to my client. And here we can see those yellow cubes. It's basically what was changed after some calls, which were happening. So basically, we have some red numbers. It's something was stolen from our warehouse. Maybe something was broken. But that's basically how the application, the structure of the application, real-time application looks like on Azure. So we have SignalR service, we have Azure CosmosDB, and we have our Azure functions. And to go back to summarize a bit, the main component for us was Azure Functions, which we used to implement business logic. And as I already showed before, there's a variety of bindings and HTTP triggers, and combining them differently allows us to save a lot of space, a lot of code, and a lot of time. So Azure Functions is not just scalable, like brick, which managed by Azure, and we don't have headaches from like hosting, deploying, and taking care of all those things, but it's also much less code and much easier and simpler to use. We can concentrate on our business logic, and having Azure Functions and Azure CosmosDB with a change feed functionality, which gives us basically event sourcing out of the box with ability to retrieve all the history. We really can concentrate on what to do with our data and how we can process this data. And we don't need to like think how to properly store it, how to optimize all those things. Azure gonna do all these things for us. And last thing is, it also gives us simplicity in building our components, our separate components. We have independency in our Azure functions, and our Azure CosmosDB is also absolutely like separate brick, which has the whole ecosystem basically, because change feed is not only for pulling data, it's not only to store data and pull data out of there. We also can use different connectors. For example, if we want to have real-time calculation aggregation, we can use Apache Spark. Or if you want to transfer our data from our Azure CosmosDB to another data store, we can use change feed and transfer it to, I don't know, blob storage. So basically, many other very useful, I would say, features are available because it's Azure and it's all integrated between each other. So that's basically end of my presentation. I hope that it gave basically this application and this example gave a bit of understanding how easy it could be and how flexible is to use Azure Functions with all the functionality. And thanks a lot for the attention. I finished, I guess, just a tiny bit faster. Maybe there's some questions